Alright, this is 14.2, part 2. And we're going to look at the head-to-head criterion. If a candidate is favored when compared head-to-head with every other candidate, then that candidate should be declared the winner. What we're going to be able to do is, what we have to do here is do a pairwise comparison to see who would win in terms of head-to-head. So we're going to do the rounds again. And that's the fairness criteria. It's also called the Condorcet criteria. So suppose that we have 4 candidates that are running for mayor of Springwater. Alvarez, A. Buchanan, B. Chekansky, C. And Davis, D. The election involves voters ranking the candidates with the results shown in Table 14.17. So as we can see, we have, 4 different choices, first, second, third, and fourth, because there's 4 candidates. In Part A, if there's one candidate who's favored over the others using head-to-head comparison. So we got to figure out, we got to use that pairwise comparison and figure out, who is the winner. So let's go ahead and start on that for Part A. So first of all, I need to know how many rounds I have. So I use the formula C equals N times N minus 1 all over 2, where N is 4 in this case. 4 minus 1 is 3 over 2. So this equals 6. So I'm going to have 6 different rounds. And those rounds are D versus A, D versus B, D versus C, A versus B, A versus C, and B versus C. So we're going to have to check each of these rounds, see who the winner is, and then go from there. I added a page on the next page so we could write this out. So let's go ahead and get started for Part A. So the first one was D versus A. So you need to look at that table 14.17 and see who wins. So D was in first place, so D wins the 129 votes. And then I look through A. Well, the next one is 90, so A gets that because A is in higher order than D. And then the next one over is 87, so A is over D, so A gets the vote of 87. And then the next one over is 78, and D is over A, so D gets those votes of 78. And then the last column, A is over B, so A gets the votes of 42. When I sum these, D gets 207 votes, and A gets 219. So A is declared the winner of this round. Okay, so let's go over to the next one, D versus B. Alright, so once again, we're going to go through each one. D wins the first one, which is 129, because it's in first place. Now I'm looking at D versus B. So if I look at the 90, we're going to see B is on top of D, so the vote goes to B, which is 90. And then 87, B is on top of D, so 87 goes to B. And then 78, D is on top of A. So, or excuse me, B is on top of D is what I meant to say. So it's looking at the wrong one. So we have 78 there. And finally, in the 42 column, we see that B is on top of D. So it gets 42. So D is 149, and B, when we tally that all up, B is 297. So B is the winner. Winner, winner, chicken dinner. Alright, let's go to the next one, D versus C. So once again, look through every single column, and when you do, you're going to find that D wins the first column, the 129 votes. C wins the second column, so it gets 90 votes. C wins the 87th column, so it gets 87 votes. C wins the 78th vote column, and the 42. So if we tally up C, we get 297, and we can declare that C is the winner of that round. Alright, next one, A versus B. So we have A and B that we're looking at this time around. So if we go through the columns, we see that the first column, A, wins. The second column, which is 90, A wins. The third column, which is 87, B wins. The fourth column, which is 78, B wins. And finally, the last column, 42, B wins. So if I tally these up, 129 plus 90 will give me 219. And if I tally up the B, I get 207. So A wins this round. Next one, A versus C. Okay, so we have A and C here. So A wins the first column, so it gets 129. A wins the second column, so it gets 90. C wins the third column, and it gets 87. It wins the fourth column, which it gets 78. And it wins the last column, which gets 42. Now we have to add these values together. So for A, 129 plus 90 is 219. And for C, 87 plus 78 plus 42 gives me 207. So the winner is A. All right, and finally we have this last one, B versus C. So you look through the columns and see who wins or who has a higher order. And we see that the first column, B wins. So they get 129. The second column, C wins. So they get 90. The third column, B wins. So they get 87. The fourth column, C wins. So they get 78. And the last column, C wins. So if I add these up, the total for B is 216. And the total for C is 210. So B is the winner. Okay, so tally these up. So if we award everybody 1 point for win, let's see what happens. So A has 1, 2, 3 wins. B has 2 wins. C has 1 win, and D has 0. And how you can check this is you tally them, and it should equal the number of rounds you have. So the number of rounds is 6. 3 plus 2 plus 1 is 6. So yeah, we're okay. All right, so the overall winner is A. So A is the winner. Okay. All right, let's go ahead and check out B. So part B, and it appears that I didn't leave enough room. So I'm going to go ahead and record at the end here. So just give me a moment. Okay, so I'm on part B, and I'm looking at table 14.17, and I'm under the head-to-head criterion objective, which is objective 2. So part B reads, who wins this election if the polarity method is used? Does that result violate the head-to-head criterion? So who wins the election if polarity method is used? So when I look at the first row, and it appears that D has 129 votes, A has 90, B has 87, and C has a total of 78 plus 42. And that'll give me 120 votes. So the winner is D. So winner using the polarity method is D. Does that violate? Yes, because we'd expect A to win. Alright, so that's part A. Part C, who wins the election if the border count method is used? Alright, so we're going to do that here, border count method. Okay, so I'm looking at the border count method with table 14.17. And remember, border count method is a ranking system. So I have to look at all the candidates, the first being is D. So if I look at the table, I see that 129 votes, D came in first place, so it gets 4 points. So you multiply the two together. And then for the 90 votes, D came in last place, so it gets 1 point. And then plus 87 votes, D was in last place again, so multiply by 1. And then 78, D was in the second to last place or third place, so we're going to multiply that by 2 points. And then finally, the 42, D was in last place, so multiply it by 1. So when I do the math, I get 129 times 4. So 129 times 4 will give me 516 plus 90 plus 87 plus 78 times 2, geez Louise, I get 156, and then plus 42. So if I add those values together, I get 891. All right, so then we continue on, so we need to know what C is. All right, so C has 129. It's in last place, so it gets 1 point for that. So multiply those two together. For the 90 votes, C was in second place, so multiply that by 3. Plus 87 votes, C was in second place, so multiply that by 3. For the 78, C is in first place, so multiply that by 4. And in the last one, C was in first place again, so 42 times 4. So when we do this, I get 129 plus 90 times 3 is 270, plus 87 times 3 is 261, plus 78 times 4, and that's going to be 312, plus 42 times 4 is 168. So what we're going to do is we're going to add those numbers together, and we're going to get 1,140. Okay, so that's for C, and we have D as well. Now we're going to look at the other ones, which is A and B. So I'm going to go ahead and look at A here. So A says for the 129 votes, A came in second place. So they get 3 points, plus 90. They came in first place, so they get 4 points. Plus 87, they came in second to last or third place, so they get 2 points. Plus 78, they came in last place, so they get 1 point. Plus 42, they came in third place, so they get 2 points. So if I do the math here, 129 times 3 is 387, plus 90 times 4 is 360. Plus if I double 87, I get 174. Plus 78, plus 42 times 2, and that is 84. And when I add these values together, I get 1,083. All right, so there is D, there is C. We need to do B as well. So just to keep this on the same page, I'm just going to put a little arrow up here, and I'm going to go ahead and I can do B here. Okay, so for 129, B was in third place. They get 2 points. For 90, B was in third place again, so they get 2 points. Plus 87, they're in first place, so they get 4 points. Plus 78, they're in second place, so they get 3 points. And lastly, 42, they're in second place, so they get 3 points. So 129 times 2 is 258, plus 90 times 2 is 180. Plus 87 times 4 is 348, plus 78 times 3 is 234, plus finally 42 times 3 gives me 126. And if I add those up, I get 1,146. So here's the deal. Which one's the winner? Using Borda count. Well, I'm looking for the one who has the most amount of votes, and that seems to be B in this case. So B is the winner using Borda count. So the next question is, does it meet the fairness criteria of head-to-head? And the answer is no, it does not. So does it violate? Yes. Does it meet it? No. Okay, so it does violate the head-to-head criteria. Okay, so that's just the Borda count method. We still have D to do. Who wins this election if the polarity with elimination method is used? Does that result violate the head-to-head criterion? So once again, we're going to look at table 14.17 for this. And we're doing polarity with elimination. So when we did the polarity method, which was part B, we saw that D was the winner with 129 votes, okay? So polarity method says that I have to take and find out if that's the majority. So to do so, I have to take 129 over the total amount of votes, which is 426. And I got 426 by adding 129 plus 90 plus 87 plus 78 plus 42. And when I divide these two, I get 0.30. That is not enough. So that is not the majority, even though D won. So the polarity with elimination says, eliminate the person with the least amount of votes. And if we look there, we're going to notice that B only had 87 votes. So we're going to eliminate B. Okay? And if we do that, everything shifts up. So if you look under the 87 column, B was there, so now B is gone, so C gets the votes. Okay? So if you eliminate B, D has 129 votes, A still has 90, and C now has a vote that went to D, or that went to B. So now they have 87 plus 78 plus 42. So basically, out of that column for 87, I took the second place vote and moved it up. And when we do that, we get 207. So the winner now is C. But the $1 million question is that over 50% of the vote? We got to check it. So we take 207 divided by 426, and we find out it's 0.485. So we're close, but we did not get enough votes, so not enough. Once again, it has to be over 50%. So I continue on. Who has the least amount of votes now? It's A. So I eliminate A. So there's 90 votes. If you look under the 90, if A is eliminated, C now gets them. So we have D gets 129. C now gets the 90 votes. Because remember, if we eliminate A, C moves forward. So C gets 90 plus 87 plus 78 plus 42. And when we add those all together, we get 297. And once again, we have to check it. So 297 over the total of 426. If we check this, we find out we are okay because we are over the 50% mark. So we're cool. All right, so who's the winner using the polarity with elimination? Winner is C. Does this meet the head criterion? Does it violate the head-to-head criterion? Is the wording on this question? The answer is yes, because the winner should be A using that method. Party, who wins the election if the pairwise comparison method is used? I'm going to put a little note, look at A. We found that candidate A was the winner using pairwise method, right? And if we look at a pairwise method, we notice that it, it's talking about like head-to-head is the criterion method. So does it violate it? No, it does not violate it because A is the winner. We expect A to be the winner, comparing each candidate head-to-head with every other candidate. All right, so we're done with this example. Yay! It's a very long video. Okay, so objective 2 is done. So I'm going to go ahead and finish up this next page here, even though I know the video is getting a bit long. The only method that does not violate head-to-head comparison criteria is the pairwise comparison voting method. Okay, so that's the answer for that. All right, let's look at objective 3, the monotonicity method. This next method, or this next criterion, remember this fairness criterion, is when there are more than one candidate, when there is more than one election. So, for example, before an election is held, the voters may discuss each candidate's strengths and weaknesses. At that point, an unofficial election is held to see how many voters, or how the voters stand. This is called a straw vote. The official election is held after the straw vote. If you want an example of this, I believe they elect the Pope this way. You know, the members of the clergy talk to each other, they have a first vote, and then they have an official vote. So that's what they're talking about here. So monotonicity criterion, a candidate who wins the first election and then gains additional support without losing any of the original support should win a second election. So the next video, I'm going to go ahead and start on this next example. So the next video will start here, and we'll see this example and run through objective 4.